Now, on the automated presses, where everything is done automatically, we had some impurity must be injected to keep the record flat. And you normally use polystyrene. And that's the reason your records, very many of them, are noisier today than they used to be, because of the impurities they're put in to keep them flat off the automated presses. And the only way you can get around this really is by very slow curing of pure vinyl. Bring it down very low in temperature, and this takes time. And this is something that they don't want to do with automated presses, as you might understand. They're out to make money. They want to reduce that 75-cent cost per record to 70 cents. And that's really a sort of a false economy when that 75% record is selling on the open market for $7.77, isn't it? When not 5 cents out of $7, almost $8. Yeah.
Make the new records have
With pictures on the records. It's done by pressing right over. We've done a couple this way. You have to use the proper plastic. It's kind of critical.
It's not vinyl?
It's vinyl. We used vinyl to do it, and it worked. Our major problem was getting the proper material in the center and then getting the temperature of the vinyl right so it didn't tear the picture when you press the two together.
It's just different colors.
Mm-hmm. It was actually a photograph, and we pressed the record right onto the photograph. But the major problem we had in working with the process was tearing the picture. The plastic float would tear the.
So you use clear vinyl?
Yes, we did. Vinyl, as it is manufactured, is clear. It has to be colored. It is colored black with carbon black. In fact, we ran a test a while back. Some of the guys said, well, if that's the case, maybe the carbon black, being an impurity added to the vinyl, causes noise. So we ran some records that had no black in them. We ran various colors and clear. And we didn't really reach a conclusion that the noise was shifted that much. In fact, some of the fellows thought that the black records sounded better than the clear ones. The clear ones had nothing added. Well, I don't know. It certainly wasn't a conclusive test. Yes. They're using lasering and digital recording right now. The Japanese are using a system like that. It can be played back with a stylus. They're using those to record the digital information of burning into the record as it's rotated. Right now, most of those systems are still laboratory type systems, and it's far too expensive for the home use. If we can get the digital end of the thing down in cost. Right now, the major problem is analog to digital encoding. The devices to do this for audio in real time are expensive. And once we get that down, I think digital recording is reasonable, where we'd use a laser.
Would the laser records be able to be played on regular home systems?
No. They're a completely separate system. However, it appears now that they could be manufactured in a press, which would keep the cost of the records down. The German video discs that were made were manufactured in a record press, the Teldex system. And that was done with just a regular groove, and you played it with a regular stylus. Something else. And they even used an audio recorder. We said, how'd they get an audio recorder? What they did was reduce the speed of the tape. How many of you have heard of half-speed recording? Well, heard of this. Well, the Germans recorded the video. It took them 6 hours, I think. I think it was either 6 or 7 hours, about that time period, to make one 20-minute side. They had to slow it down. Well, the first place, the audio recording system was not designed to respond above 25,000 hertz. So it had to be reduced where the highest frequency was commensurate with what the audio system would reproduce. So they had to slow it down. Now, what does slow speed recording get around? We've been talking about this plastic deformation problem a lot. That is one problem that's reduced by half-speed recording. Even the cutting process, there's a certain amount of this plastic being deformed. It isn't a super clean cut like you're cutting in a fluid. You're cutting in a solid. And you have this plastic problem. If you cut it at half speed, the problems are reduced at high frequencies. And some of the high frequency distortions are reduced if you cut at half speed. And that's the primary reason for doing it. Be to improve the high frequency of the distortion products and have them reduced. And we originally did it a few years back when we didn't have cutter heads that were good enough to get high levels, super high level 45s in real time. and we found that the cutter heads would work better if we did it at half speed. So back in the late 50s and early 60s, we were doing some half speed recording to get the high level 45 RPM records. And that was the reason we did that. So we get the level up without getting distortion. Yeah.
Say that normal master presses is between 1,000 and 2,000. No,
Yeah, someplace in there.
What about these albums that you get paying the extra dollars for it taller?
They'll probably hold it down to a few hundred, and then they'll change them. We were doing some direct discs, and I don't think we ever ran over 500 on one set of stampers.
Would that change the frequency response of that album in relationship to, say, the
Yeah, if you could hear one that was the first one off and then hear the 2000, you could hear the difference,
4 or 5?
particularly in the high end, loss of the high end. The high ends, which are the finest part of it, that's the finest detail on there. If you're talking similar to photographic detail, wears away first, and that's what's lost. So we were limiting it to 500 on the direct disc we did. We did Pharoah Morris. I don't know if you've ever seen the direct disc album he has out, jazz album. We've done 2 or 3 of those. And that's all done that way. In fact, very, very close control is kept. Every 100 records, pull one off and listen to it and compare it to the first one, particularly where the levels are high and there's high frequency detail. And once you sense anything at all happening, it almost has to be a subjective thing. It's a very difficult thing to measure. Do it by listening, I suppose. Maybe with a good scope system, you might be able to see it. But we did it by listening. About the 500th, when you begin to hear it, we'd stop there and put in a new set of stampers.
Thickness of the vinyl have anything to do with it?
No, not really.
That
The type of vinyl might. Some vinyls are better than others. Thickness really wouldn't have much to do with it. The Japanese supposedly have a high-grade vinyl. We don't. Some of our vinyls, the highest grade vinyl we have, came from Iranian oil. But we don't have any of that. And they say that the Alaskan vinyls are not as good. I guess the Japanese are still using Iranian vinyls. I suppose we get that problem solved, and that'll eventually get squared away. But they say the vinyls are not as good as Alaskan oils. And much of our plastic is either made, a lot of it's made in California, then shipped east. That's a petroleum derivative. Yeah.
I was just wondering, we got well, one of the record companies like Columbia House or something.
Uh-huh.
And we had a couple of them under a black light, and like the ones that we bought in the store looked all right, but the ones that we got from the record company, black light.
But you might be seeing the polystyrene in it. It would keep them off an automated press. Or then they,
Cheaper records or-
yeah, the problem is just they're trying to make more money on them, pulling the cost down. A lot of that really is false economy. You know, if someone brings me a tape or wants to do a recording, you know, we're limited in time. You can't put an infinite amount of time aside. They say, how much time can I put on the side of the record? And I usually advise people, depending upon the material, if the material is dynamic, where there's soft and loud passages, fairly equal in time, I say, well, you can go up 24, 25 minutes. But if it's loud, I tell them to hold it down 20 or below. And they say, why? And because I can't keep the level up on the record. I'm forced to reduce the level, and I think you're going to give the customer an inferior product. In fact, many of the records that you buy today will be 15, just slightly under 15 minutes per side. You say, why? Because the musicians union. If it goes over 15 minutes, they're required to pay the musicians performing on that record for another session. So if it's held just under 15, they pay them for 1 3-hour session for one side, 1 for the other side. If one side goes to 16 minutes, they have to pay them another 3-hour session. That's the reason for it. Yeah.
Do you know anything about picture discs? Why they were so bad?
You mean the one with the picture in the center?
You know, the ones with the pictures like on the disc. They were actually. They're not the ones that have the picture and the plastic.
You're talking
over it.
about where the picture's recorded on it
Yeah.
and played back.
I mean, it's really the color of the vinyl, whatever it is, whatever the record's made out of is a picture. It's not like a picture inside plastic that records on.
The ones were made in Japan? Japanese?
Video distinction.
You're not talking about video discs, the ones played back through television.
No, I'm talking about regular. You see those discs, the records they
Yeah.
have out now? Well, they don't have them out anymore. They have the ones, they have Like,
I would imagine they were getting the same problem we had. The yield rate was bad. We were having a lot of problem tearing the pictures up in making them. And it could have been the vinyl they had to use too. We tried several types of vinyl on the whole thing. All kinds of things we were trying. It was for a company in Newark, and we never did get a good system that I felt was really going to make records at high yield rate.
Because like I have a disc it's like a picture disc, right? But it's,
Yeah.
I mean, you just can't play it because it skips all over the time.
It might have been a warped surface again. This was another problem you had in the surface did not stay flat. It would tend to do this, buckle in places. You tend to leave the picture, and you can't imagine the problem we're having with that thing. We tried all kinds of agents in between there, to make it seal, and it just never worked well. The Japanese made some, but I don't know what their yield rate was. Yeah.
I noticed on the digital record that just came out, they said they put, instead of putting it on one LP, they put it on, even though the same amount of time, they put it on two LPs. Is that for a better frequency
They're
response?
probably trying to get better frequency response and keep the dynamics up.
Because of the
Excursions you get. Right. Another thing that you can do, and you've seen this on some 12-inch 45 disc, is to run the record a little faster, and this keeps this velocity thing up. Remember, we said we got into a problem when the velocity of the stylus matched that of the forward motion of the disc. Well, if we run it faster, we can record it with a higher velocity, bring that velocity up and match that, and get away from that problem. That's the reason some of your disco LPs ran at 45. In fact, one of the direct discs we did at 12-inch was run at 45 RPM. We recorded in the studio and did it at 45 RPM. I know it's funny. You see a 12-inch 45 RPM, but we were trying to hold that velocity up, and it turned out to be a pretty good disc that way. We had to cut the time down on the side. We were running about 12, 13 minutes a side on a 12-inch disc. But you can do that, get away from it. What I thought I'd do, what time do we have? Okay, we'll show you a little bit about what some of the things was talking about look like. Oh,
Flip the channel.
there it is. That's the cutter can that you're seeing there. It's actually cutting records thing, and you can probably hear. Yeah, you can hear us talking in the background. Right? So it could be a record that's all in Hebrew. He's pulling back, but this is the expensive item we talked about. Very good it sounds. But it's getting driven across the record with this, which looks nothing more than a gigantic lathe. That's what it is. It's just precision lathe. This whole mechanism is a very massive mechanism, does nothing more than support the cutter. It's made massive so nothing will move and warp. And this is being driven across here from a motor that's right down in the groove. This is a microscope that's used to examine the grooves that have been cut. You see a tube that comes out here. That tube. When you cut the record, a very fine thread of the material is cut. And you can suck back up into a track. It's like a little machine. That's the name for that thread is SWARF. SWARF. How they ever came up with a name like that, I don't know. Oops. Well, we also can determine the effective sound level, pressure level, and we have also described already. The pitch the record was running at. Lines per inch. We have it described on the sound pressure level indicator. Right there is running at about 210 lines per inch. That's the number of grooves in an inch. We measure most inches of record and measure 210 grooves. There, it automatically banded itself. And now, when it bands itself, this is simply an indication of the drive motor speed, and at full speed and drop back. This is the thing we talked about that has the little wire hooked onto it. That controls the. There's your scope. Now, what you see on the scope there is the combination. Notice how we have the thing rotated 45 degrees, and that is what a stereo signal looks like. This indicates now that it's slightly heavy to the left, and it tipped left. up on the left. Third love balance, we can like, oh, that would be simply a straight line. There it shows, there's some other voices coming in. It went down, now it's balanced slightly to the right, depending on where the voices are in the stereo perspective. Now, he is in mono, but his voice doesn't look like a straight line. That's because his voice has been doubled through the harmonizer and also reverberated. The reverberation into his voice and has been doubled through the harmonizer, which makes it look that way. So I can't pull him back on the scope. You can see the paper photo off to the left, it's driving around, was going to be running. I don't know how to. But that's the tape machine. You can see it running at 15 inches. Just a standard paper for driving. The previous system, this tape is not doing previous. It was a pretty straight tape, but there's not a lot of diamond. It's not pretty good. This is a shot of some of the other electronics we talked about. This is some of the old simulcast equalizer. It's a knock-in equalizer. And it does a pretty decent job. It lacks a little bit of headroom. It's just very hard to use it. These are a pair of Euro limiters. We use the stereo limited. The box you can see down here is a burning noise filter. And that's nothing more than a device that turns off the low frequencies and the high frequencies at the same time. So there's no sound there. Bigger bang, going down out things makes no sound there. This is part of the console we used back in 1960. And since we bought all the new fancy equipment, we found out that the electronics and this is all vacuum was quiet and they solid state stuff with time. So we ended up giving them the button with the driving and different things like that. It knows throw it away, so it's better than solid state. This one being up here is also used to tell us in and out of phase content. Now especially so that it measures what's in phase and what's out of phase. Similar to what you see on the scope. It gives you an average reading of what the scope shows in instantaneous. That's the meter at the very top. And the meter are left and right. This is left and right monitor. They're out the run. Full monitor. Now, there we are. We're just finishing that side of the record. The head was driven in. This was done with the motor. It's driven into the center of the record. The motion of the drive is stopped. And we put a continuous groove on there, and then we lift the cutter head up. That makes what we call a locked groove at the end. On very old records, you may see one when it goes into the center, the arm moves back and forth. It's called the century. Then we put on the when we made the that's really a look down through the microscope with the television camera and get an idea of what we see. You can see the grooves there moving, wailing around. The dark area is the groove. The light area is what we call land, or the uncut space between the grooves. But you can see the motion of the grooves, and hopefully they don't cut over into one another or touch one another. Yeah.
So the reason they wiggle is because it's different sounds.
That's right. That's the sound. That's the, what we're doing is moving it very slow, moving it very good, so you can see this effect. When you're looking at it with a television camera while it's in motion, it's just a blur because the motion's so fast. Now that's one problem using television to watch it rather than a microscope, because the television blurs it much more than the eye does. Now, well, you can see here that the groove, someplace appears to be wider, narrow. This is part of the stereo effect. What you're seeing there is the turntable moving. This is very what you can see on television if you're actually recording at the time. It just appears all in a straight line because the television can't sense the changes in dimension. If you make it eye, watching it with your eye, you can see it. Because the persistence of the television camera tube is much longer than the eye. It has a very much of what we call an integrating effect of adding everything up and making this look like. Maybe you've seen this sometime on some TV shows where there's fast motion on a film and it's blurred. This is part of that memory. And what you see here, I'm going to show you, is a mark that's put on the record. You may see these on some records by the advanced ball. There's a device on the stutter head that rides on the record just ahead and off to the side of the stylus. And what this does is determine the depth and position of the cutting stylus with respect to the record. It's not a cut deeper. What you do is put bias on the coils and force the stylus down. Or if you want to bring it up, you put the reverse bias on and bring it up and down. This spreading motion in the lateral movement is done by varying the speed of the drive motor. This DC on the coil. It's counters the magnet moves if I'm not doing it. While we're doing queuing up the tape, at the same time back trying to see what it was. They're getting ready to start. This is what it looks like from above. They go start cutting the record. There we go. Of course, you can uncut lines. There's nothing on there. This is what we're cutting here. I guess if you're liking it's modern music by Manny Thomas. The problem is we should like this. Sure, there's nothing. It's good if it's not from the right. It's I don't understand either. It gets material. To do the mastering now, you figure somewhere between $75 and $100 a record. Both sides. That's what's running. These blanks that you cut on used to cost us $1 a quarter, and now cost $15 a piece. Styluses are about $30. And stylus life can vary anywhere from 10 records, and I've seen go along 100 hours. It's still cut good record. And the styluses are normally made of ruby, cutting, not sapphire. The sapphires have the wide variation life. The rubies are anywhere between 50 and 100 hours. Now the top on the recording electronics, these are the meters we can drive right into the recording amplifier. And we have another meter that was off of a pot that was off to the side of those 2 meters, a big black pot there. This then tells us what we are with respect to the standard RIA level. We can go as high as 10 dB above and 10 dB under standard level. So we can cut a record that's 10 dB hotter than what standard should be. He's showing a picture of the Berlin filter and the patch bay. This patch bay is not normal, by that I mean where everything is had a certain pattern. Everything's patched. So it looks like a jungle. But we can patch the equipment in any configuration we want. Where if it's normal, we could couldn't change it. That's the setup to the signal processing. We can do quite a bit of signal processing. Like where we cut a good records. The clarifier that you see here is another thing that it's our answer to the old Apex system. Dr. Blackman they have university. What we did was take the planes of AFEX and said, what do we have to do electronically to make a device that'll do this? And we came up with this clarifier. Well, AFEX finally patented their system. we're looking for a patent, we are doing the same thing. It has similar effects. Ours is in the image broadening effect. And it worked out pretty well. We're using it. Studio in California, studio in Chicago. That's really what's involved in the cutting process and machinery that's in there. Again, we're winding it all. The record machinery still outside, you see. This was his first attempt at running fellowship camp. Old movie #1. It was a pepper headache because of 85. Yeah, we did press the roll. Most people say hi.
So what would be an average cost?
Yeah, that gets really pretty hard.
What would be an
Cost?
average cost?
For normally you can figure on a 45 running in the neighborhood of 1,000, 30 cents a piece, 35 cents a piece, depending on what you're doing. LP depends upon the jacket. The LP could run anywhere from, a jacket could run anywhere from 75 cents a piece to $2 a piece, depending on what you do on it. You could go to a pocketed jacket and a picture on the inside and folding and all this. It's very expensive.
Do that also.
No, we don't do the print.
Just have
We have a printer that does it. We do the shrink wrapping and the fabricating of the jacket. We do not do the color printing. You have to send that out to have it done. But when you go to, next time you go to produce a record, which a lot of you may be doing now, if you're in this, you'll have a little feel for what's involved in it, I expect, in the thing. The major cost, the major money to be made is somewhere in the middle. It's not in manufacturing it. It's not in recording it. People sell the record. Any other questions on? Yeah.
What's the best way to clean your records?
What I would advise is a very mild solution of detergent like Joy or something like this, very mild at about body temperature. Clean it with this and rinse it with distilled water. Get all the particles and don't dry it with anything that has any lint in it. Everything completely lint free. Paper won't work because you'll pull pieces of the paper out. The particles come out of the paper. It'd either be allowed to air dry or with something that's completely lint free. And that usually will work pretty good because the detergent will usually pick up the dirt in it. And then rinsing it will usually carry it away. But
Don't worry about warping.
no, not if you keep the water right at body temperature. So it just feels comfortable for you. If you make it too hot, you can warp it. And then you always get the case where you have a warped record, can you straighten it out? Sometimes you can if you'll put it between either aluminum plates that are warm and let it cool very, very slowly. If you allow it to cool rapidly, it'll take the warp back on. If you let it cool slowly, it may take it out. Again, it may not. Depends upon the plastic and how strong the memory in the plastic is.
Those dishwashers can.
Yeah, they'll usually do a pretty good job. But you can do it just as easily at home. If you just use a very mild detergent solution and then some good clean water, preferably distilled water. Has nothing in it because many tap water will have some chemicals in it, calcium and sodium and so forth, and they'll leave deposits. They won't really ruin the record, but they'll still produce foreign material in the record you don't want there. Where distilled water usually take care of most of it. And you keep it pretty clean. Oftentimes we'll be working with very old recordings, transferring them to tape, or producing another record from them. We always clean them that way before we do anything with them. First thing we do is clean them. Mild solution, just about body temperature, and then rinse it in distilled water and then play it. Then try to protect it again. But that's hard to do. Almost has to be sealed in something. Yeah.
Going back to the tones that you would like to have recorded on the tapes that you get, you say the one tone as far
That would be your primary level set tone. This would be 0 level. I'll also determine this to be my 0 level from you. I have engineers, and I think we've gotten them out of it, will give me what they say is 0 level. But there's nothing in that tape ever gets above -6. So that really wasn't zero average. Or they'll give me zero level, they have a half a dozen things to go plus 10. What? And so if that's really your zero level, you want to be your loudest passages to come up to zero average. That is in particular if you're using noise reduction. Because if I set up the noise reduction system assuming that you're 0, 0, and I'm decoding, well, this is magnified by the expansion range of the decoder. If it's 2 to 1, I may end up, if you're 3 dB down, I may end up being as high as 10 dB down in some passages. And it won't sound quite right. But that's important that we get the levels right. So the 1 kC establishes the level. The 10 is used for establishing equalization and azimuth on the tape player. And the 1 is used primarily for equalization again, 100 cycles. Any other questions on? Yeah.
A question about doing direct to disc
Mhm.
these. When you're setting things up, did you have to have the musicians play through like what they're going to be doing for the entire side so that you can get all your levels checked first?
No, we normally don't. In a case like that, what we'll do, the director will know where the loud passages are and what he's going to do. He'll be familiar with the material, and he'll usually play the loud passages for us. That's the way we've done it in the past. We let him play the loud passages, or if it's coming off a digital tape, we've transferred from digital tape, similar to the machine you have here. And what we've done there is knowing where the loud passages are, went in and found them and played set up to them. And also went and listened to some of the soft things and see if the dynamic range was too great. If we were getting to the point where the rumble and background noise was going to cause a problem. But most of the players that play these things are pretty good. And you don't play them on El Chivos. You play them on good systems. And you pretty well assume that turntable is going to be good and quiet. Yeah.
You're saying when you do this direct to disc, you have to actually set up this whole system wherever you're recording?
We've done it all in the studio. We've done it. Or the next closest thing to it, of course, is a digital tape brought in. We've done it from that, but we have done it in the studio when it actually come in and played. We see all of you are too young to remember, but when we did this back when I first started recording, even as late as 1958, 60, that's only 20 years ago. We didn't have multiple track recorders. All we had was 2 tracks. Everything, and I thought I was fantastic when in 63 I got a 4-channel machine. I had the first one in Columbus, and that's a fantastic piece of machinery, a 4-channel recorder. And all the Beatles recording were done on 4-channel. That's all they had. Yeah.
How much custom designing of 45 jackets? Like I've got an old Beatles 45. It's got a picture of a group on the front. It's almost like a miniature album jacket. Do you see much of that anymore?
Not on 45, no. Because of the expense. Unless you're selling very many of them, it's too expensive to do. If you're going to sell a lot of 45s where you can amortize the cost of setting up the color jacket over, say, 50,000 records or 100,000 records, or even 1 million, sure, you could do it then. Any other questions? How many of you want to become master? Yeah.
Yeah, no.
Statics? No. No. Some of the records used a graphite in with the carbon black to try to get rid of it. But so many people complained about the surface noise. It increased the surface noise. Used graphite with the carbon black. We don't do it. We try to stay away from it. But in the winter, it's a problem. It's much more so in summer. Oftentimes, washing them with distilled water will remove most of it. Hold it down. It's a hard thing to get away from and stop. See, the way we got rid of this on tape, you've all worked with the tapes, the flat black mat on the backing. Well, that has a conductive material, and if you put a meter across it, you can meter. It's conductive. And that's the way we keep it from happening. If you ever have an old tape, a lot of guys, when they work around tape, they put their finger in and work around. When they used pure Mylar on the tape and used Mylar leader, you could get this static electricity effect off tape too. In fact, you get one whale of a shock off of it. You have to have your hand up close there, and the clear Mylar shot through at high speed, it won't knock you back off your chair. sitting on a chair and get zapped by the tape machine and the static electricity. And I don't think it'll happen anymore. That's why one reason we use paper leader. And you've all leadered tape. You can do it with Mylar paper. In most of the stuff we produce that are run on the high-speed machines, we use paper because it won't build up static electricity like Mylar will and zap you. And in the winter, it's even enough of a problem with Mylar that you can hear it discharging to the playback kit. Put snaps on the record. I don't like that. Pops and clicks are bad enough. I'm putting adding some. Well, you all want? Are you all going to become recording engineers? Is that? Some of you are musicians, I believe. What? There weren't too many. How many are musicians again? Oh, quite a few. Quite a few of them musicians. You all wondered who makes the best recording engineers. Is it somebody that's a musician? Not always. Is it somebody that's electronic bug? Not always. It depends. It's somebody that can really hear how to balance the sound. When we first started our studio, there were no engineers around anywhere, so we had to train some people to work and we do an awful lot of industrial work where we're putting together soundtracks for motion pictures and slide films, radio spots. We do some syndicated radio shows, those kind of things, which are big and very time consuming. And the guys can become very fatigued after listening to 45 hours of Mother Earth news or something like this. It's pretty wicked. But the same thing can happen to you when you're listening to music. And I don't know if you've ever tried this little experiment or not, but to be listening to something for a period of time and do a mix, come back and listen to your mix about an hour later. Allow about an hour elapse where you go away and just relax where it's nice and quiet and see how different it sounds to you. And this fatigue effect. We ran a study at Ohio State, and so have the British run a study, and we came up with the same results that they had. That, they said that all rock singers had permanent damage from the sound level. And this study indicated that this was not true because most of the tests had been run a very short period of time after they were subjected to the high sound pressure level. That the amount of time it takes for you to recover is directly proportional to the level at which you're listening and the amount of time which you listen. So if you're mixing in a room where the client that you're mixing for wants it uncomfortably high, you might want to stop for a little while, leave the room, and depending on how high he wants to hear it, how long you want to leave it, an hour or two, then come back and work on it again because you'll hear things a lot better. In a rock band, they found that working at these 115, 120 dB sound pressure level, it might take as many as 72 hours for the hearing to return to normal, which is a fairly long time. And where what you're listening to may only take an hour or so to return to normal. And fun thing, try this sometime while you're mixing and leave for a little bit and come back and see how different things sound. One of the major problems we have in disc mastering, much of this machinery, you might say, well, it's super quiet. Not so. We have some vacuum. We have to remove this thread that's cut off the record with the vacuum. And the vacuum it's the very sound of rushing air. And there's certain parts of your spectrum that it'll affect. Particularly the higher frequencies in around 5,000 to 8,000 cycles in that region. And if you try to equalize another tape on the machine after you've been mastering for a period of time, your whole hearing system has been affected by this air noise, and you will not hear things right. You have to leave the room and come back after a while. So when we normally setting up to master a series of this thing, we may listen to 2 or 3 of the tapes ahead of time to see if they're all about the same vein. If it's a long thing, like a series, we're doing the masters for a series of radio broadcasts, which is 12 sides. Well, they're each running 25 minutes a side. That's a day's job. So once we set it on one, they're all probably going to be about the same. And that way we don't worry about this problem being desensitized by the air noise. But otherwise, it's a problem because I have found myself not allowing enough time, and I've come up with some bad records because I've equalized them wrong. They said, well, gee whiz, that thing doesn't have any mid in it at all. And I cranked the mid range to compensate for my loss of hearing there, and the record's not bad. Too much mid range in it. However, if I go away for a half hour or 45 minutes and come back, I'll hear it all right. It takes about that amount of time for the hearing to return to normal. And gets into another favorite thing that you've all experienced, whether you know it or not. It's what we call psychoacoustics. And that's what we based this clarifier on that we developed, was the fact that we can present things to you in a certain fashion, and it'll appear to move or appear to be where we want it to be, depending on how we present it. And we could image broaden and make things appear to be more widely separated than they were, or things more defined to the center than they were in the original recording. And we're doing this with psychoacoustics. This is how, using the harmonizer, you're using that with psychoacoustic effects. It's very strong, with very short delays. You can do some interesting things. I know you have a harmonizer. If you have a second sometime, you might feed in a mono signal to it and use your shortest delay on the harmonizer, which is 15 milliseconds, I think, and feed the same level of signal into that, only delay one channel with respect to the other, either the right or the left, makes no difference, 15 milliseconds. Then balance it so it sounds like they're the same level. See what the level difference is. You get the shock of your life. You'll close your eyes and it'll sound the same. Yet you look at the meter. One meter is reading 10 dB higher than the other one. Well, you can use this to advantage when you're mixing. This is one of those effects. You may do some real interesting things. Well, I don't do that sort of processing in the transfer system. I allow you to do that. I don't want to get into that sort of thing because I'm assuming a tape that you send me is ready to go. We always have to, and do as little as possible to it, unless there's very obvious problems. Most of the tapes we get out of studios are good. The ones that come out of the basement operations are the problems. Particularly people that have set up something and have never gone through a course like that, where they become exposed to the whole thing. And usually a class will ask me, what can I do to get more familiar with this whole thing and become a better recording engineer? And my answer is more of the same thing you're doing right now. Just keep on doing more mixing and listening. That's the only way you can really do it. It is something that you have to develop. You know, we did another interesting study. When I was younger, I played brass instruments a lot. I never had what they call, quotes, perfect pitch. In other words, I couldn't listen to a tone and say, that's A440 or that's C256 and this sort of thing. I couldn't do that. And they said you had to be born with it. And in our psychoacoustic study, we said, is this true? Are you born with perfect pitch? No. It's a trained response. And if that's true, I said, if that's true, then I could learn to have perfect pitch if I can be trained. So I used a small tuning fork and would attempt to hum A440, and then listen to the fork. After about a month, I knew I could hum A440, which was indicating it was a trained response, that you could do it. So those of you that aren't musicians, even those of you that are, this business of listening and learning how to balance things is a thing that you train yourself to do. And you just have to do a lot of it. Some people, it comes easier than others. I've had cases, a couple of my mixing engineers are musicians. One of them is a bass player who's played in jazz bands all his life and always been right beside the drummer. He's got a problem in his hearing response in the mid bass. He tends to hear the mid bass stronger than it really is for some reason, and tends to hear the highs slightly reduced. He tends to brighten things a little too much and reduce the bass a little too much in the region around 100 to 200 cycles. Knowing this, whenever I get one of these mixes, I can correct for it and straighten it back in. And another one of the engineers we're working with, what somebody else mixes and this sort of thing, what he's doing right or wrong. And in this way, he's trying to train his response so that he knows how to do it. And that's the same thing that you can do. A good mixer has simply learned how to do this. I have one fellow that started out with us when we started the recording business, a young fellow, just got out of high school. And he was a musician, played guitar, and he couldn't mix. He had terrible time mixing. And we worked together trying to point things out. Still, he had trouble. But one day, all of a sudden, it snapped. Just like it snapped in his brain. Ever since that day, he could mix. In fact, he's one of the chief engineers for Walt Disney now, doing mixing for him. He was that good. But it happened instantaneously. Don't ask me why. I've seen other engineers where it comes about more slowly, where it's a gradual process. I think for myself, it happened more like his, where one day I couldn't hear it, and for some reason the next day I could, unexplained. And any of you ever studied Morse code and tried to learn the Morse code? It's the same sort of thing. You get to the point where you can hear it just so fast, nothing you can do, you can get any fast, and suddenly it snaps and you can hear it. You can read the message, understand the code where you couldn't before. And I think that mixing in a recording and doing recording is about the same sort of thing. You don't have to be a musician to do it. Being a musician helps if you're a recording engineer, especially if there is something wrong technically in the music, because you can explain to the musicians what's wrong. Say, well, this chord structure is not right, or your timing is not right here, or you're slightly flat here. But you can learn this thing yourself without being a musician. And it really, they ask, if you're going to hire an engineer, what kind of guy are you going to hire? You're going to hire a musician or electronics buff? Who are you going to hire to do it? I'm going to hire the person that has the drive to want to learn to do it. This is overcome all the obstacles you can imagine. If you've got the drive to really want to be a recording engineer, you're going, best mixers have been girls. And these have been girls who were out of the engineering college, not out of the School of Music. They didn't have a background in music, particularly. They had an understanding of the physics of music, how music operates, but they didn't have, and they were very good mixers. Excellent feel for the material. So being a girl doesn't mean you can't mix. You can do a super job. And again, it's just hearing it. And don't be afraid to try things when you're mixing. Sometimes, well, I don't think I would turn that note. Try it, see what happens. You probably play around with it. And I think that even the people down here are going to offer advanced course. If you have the opportunity, get into that if you can sometime, because you can really learn a lot just for your recording and mixing. Once you've got the basics down, you can really learn a lot that way. And if you can get in a studio where they'll let you work with the equipment and let you mix, do it. Don't do like an engineer did to me. I had an engineer that was wanting to learn how to do this, so let him do it on his own time, his own material. Then he got the National Labor Relations Board after for not paying him for doing it. And I had to pay him $250. He came after me for $1,000. But I got out at $250, so I got kind of skittish after that. Whether I should let anybody mix, but we were letting him use the studio on his own time in the evening, do mixing in. So if you are employed by a studio and you do that, you can probably collect back wages if they don't pay you to do it. Because the claim made by the federal government is that the person is improving their skill, therefore they're more valuable to me, the employer. And that's right, boy. He's also more valuable if he goes to find another job somewhere else. And that might expensive. So just work hard at it. Keep doing it. More and more, all you can do. Listen to things. Anything you can listen to. Listen to it. Hear what they've done. When you listen, try to figure out what they did when they mixed it. Where did they place things? Why did they do it the way they did it? Fun thing if you have a system at home, if you can, sometimes you can hear what's in the stereo's perspective by taking the left and right channels out of phase with your record player. What you have to do is reverse one set of leads on the pickup. This will do it. Then you can hear the things that are just left and right, the things that sit are removed. You can hear how much reverberation was put on, how the reverberation was voiced, and all this sort of thing on the record by taking the left and right channels out of phase, because everything that's in the center will disappear. So it's a good tool to study with if you want to do that sometime. It's also a neat trick if the lead vocal was recorded in the center with no reverberation, you can drop the lead vocal off the record. But if reverberation is used, of course, the reverberation has spatial effects, so it appears left and right. The reverberation will still be there. But if it's done very dry, you can remove it. Same thing's true of an instrument. If it's in the center, you can remove it. Particularly the bass. That's where the bass is usually put, not reverberating. You usually wipe it right out of the record. Any other questions? Things we can throw at you. We're located in Columbus, and the guy down here can tell you. In fact, Jim Rosebrook was one of my students at Ohio State. Very good student, excellent mixer, and he's really come a long way and doing a great job. And Jim could tell you where you are. If you'd like to stop by sometime, we'll show you what we do. You can actually see the machinery and see how they make a record. We are a real big operation. Our major effort primarily in like I said, industrial work. Well, we do a few music things and manufacture quite a few records.
What's the name of your company?
Musical, Musicol, and they can tell you where it is. We do most of the records from down here. You're all welcome. Come by. Thank you.